Okay, so going to do a video on vectors. So this is specifically algebraic vectors. The idea with vectors, we start over here, is they have a distance and a direction. So unlike a coordinate, so if we had a coordinate 2, 3, that specifies a point, 2 along and 3 up. And that point does not move. But a vector would be written like this, 2 along, 3 up. So not to scale, 2 along, 3 up. And it goes in that direction. If it was to go the other way, it would be a minus. So just like coordinates work, minus is left and down, but instead of it being a fixed point, it will be a direction and a distance. Now if I to have up here exactly the same vector, so the start point might be different, but it's still going to move in the same way. So when we deal with algebra, I like to think about this as taking a journey. So for instance, S, Slough, R for Reading, O for Oxford. So I work in Slough, I live in Reading, and I sometimes go to Oxford. So if you were to ask me how to get from Reading to Slough, I would be able to tell you. It's obviously down the M4, but for now we're going to call that A. And that has a direction. So if you travel from Reading to Slough, which would be denoted R to S, the answer is you have to take the road A. To go home though, to go from Slough to Reading, we're in effect going the wrong way down the motorway, and so it would be minus A. Now I also know how to get from Reading to Oxford. So Reading to Oxford, you take B. So the question is, if someone asked me, what's the best route, or how can I go from Slough to Oxford? So the question would be, how do you go from Slough to Oxford? Well, I don't know. I'm sure there is a route, but I don't live in Slough, and I don't go from Slough to Oxford. So there probably is a route, but I do know, and I could tell them how to go from Slough to Oxford, but I would have to go via Reading. So this is what we do. How do you get from Slough to Oxford down known routes? And I would say, well, you go this way. So the important point with this is do write out this full method. Later on, when the questions get hard, it will stop you getting confused. So don't just go straight there if you know it. Write out the full thing. So you say, okay, if I want to go from Slough to Oxford, I'm going to go from Slough to Reading, and then I'm going to go from Reading to Oxford. Then you'll have other bits of the questions which you can use from here. So you can say, okay, Slough to Reading is minus A, and then in Reading to Oxford is B. So that's the basics of it, but do follow this method. It's quite important. Then it might give you something like this. It might say, well, there's a point here. This point is called point P. I'm going to give up on road Pangbourne. I don't know. Not sure where Pangbourne is. Compared to that. Anyway, and they'll give you a ratio or a fraction. So hopefully we know that if we have this ratio, 2 to 3, this will be the same as 2/5 or 3/5. But we'll stick with ratios for a minute. So they might say the ratio of S to P and P to O is, for argument's sake, we'll say 1 to 2. So that is saying, actually we'll turn it around, 2 to 1. So that's saying the unit in S to P is 2, and the unit in P to O is 1. So they might now say, how do I get from R to P? So again, we're going to follow this method here. How do I get from R to P? Well, you look ahead. We've already worked out S to O. So this here is in this direction. So from R to P, I could choose to go R to O, O to P. But then I'm going to be going the wrong way down the road that I know. And so you can do that, but it's going to involve then some minuses. And we want to try and make it as simple as possible. So I'm going to go the way that I've worked out. So R to P, and you can try both, and they will end up as the same thing. but try and use the things you've already done. So R to P, I will travel R to S, and then I'm going to travel S to P. Then we're going to substitute in. So R to S I know, it is A. S to P, now this is where we're looking at ratios, fractions, it should all come together, plus expanding brackets. So S to P is 2/3 of S to O. So I'll go through that again. I've substituted S to P, which I know is 2/3 of the whole road. Then I can substitute in, and this is why this method, writing out your method in full, is quite important because there's a lots going on. So S to O I have worked out is minus A plus B. Then I can expand this bracket. A minus 2/3 A plus 2/3 B. Then I can collect like terms. So I have 1/3 A plus 1 and 2/3 B. Okay, so we will do another, there's a couple of different versions of this, but this is the basics. So if we look at this one here, we have a diagram up here, and to start with they're going to ask me what is A to B. So I'm going to, again using my method, I'm going to say, okay, I know these roots here. So A to B is A to O plus O to B. Now I can substitute in. Now A to O, you're going down this road the wrong way, so it's minus 3A. O to B is plus 6B. So that's the first part done. Then they give us some more information. They tell us that AX, XB is 1 to 2. So A to X is unit 1. I'm going to put a little arrow here. And X to B is unit 2. Then they're saying, prove OX equals 2/5 of OY. So at this point, we don't worry about the proof. All we're going to do is look at what is OX and what is OY, and then we'll put it together. So over here, I'm going to have OX. Now, O to X, we're going to have to deal with this ratio. So again, I'm going to look at the way that I'm going, which is this way here. So I'm going to say, I could travel this way, but actually I want to be traveling up this road. So I'm going to say O to X is O to A plus A to X up here. So that's the route I've gone. So this is O to A is 3A plus 1/3 of, just realised I'm off the screen, sorry. So I'll do this bit again. There. I'm at a different place to where I normally am. Okay, so we said O to X. We travelled O to A to X because of going this way. So we've got O to A is 3A, and we've got A to X is 1/3 of A to B. Substitute in. We've already worked out what AB is. Oh, 6B. Expand the bracket. 1/3 of 3 is just 1, so that'll be minus A. 1/3 of 6 is 2, plus 2B. Collect like terms. 2A plus 2B. So that's O to X. Now I'm going to work out O to Y. Now O to Y is this way here. Now I could try and fiddle around going up and down here, but I can actually see a route. I can see a route up here. So I'm going to take this route here, which is O to B, B to Y. So we've got O to B plus B to Y. here. I can then substitute in, so it's going to be that and that. So O to B is 6b, and B to Y is plus 5a minus b. So now, again, can collect like terms, and we end up with 5a plus 5b. Now I'm going to look at the question. It said, prove this. So I'm going to fill this in. So it's saying OX, which is 2a plus 2b, should equal 2/5 of OY. And if you expand this, you can see, actually, they do equal. So you expand the bracket, and that's been proved. So at the beginning of this question, don't worry too much about that. Just think, okay, let me work out what O to X is. I can do that. Work out what O to Y is. I can do that. And this is just using our ratio and fractions from a previous question. And that's all good. Okay, we've got two more types. We have this sort of question here. It says, prove that it's a straight line. So we have to go back to, in effect, the definition. So say if we had our vector from the start, which was 2, 3. If I carried on in a straight line, I could add on another 2, 3, which would mean this total vector was 4, 6. So you're basically saying, as long as it's a consistent multiple of the original vector, then the longer line will be a straight line. So what we've got to do for this one is we are going to work out what nm is, then we're going to work out what n to c is. We've got to say nmc is our straight line. So if we work out what nm is and what nc is, so in effect we're doing this to this and this to this, as long as this is a multiple of this, and it can be a fractional multiple, as long as it's a multiple of this, then we can prove it's a straight line. So n to m. So on this one, n to m will be n to p plus p to m. Now I know n to p is b. Now p to m, this is a midpoint. It tells you in the question. So 1. Midpoint of p to b. So plus a half of p to b. Now p to b we can work out is minus 3b plus a. We can expand this, so that equals b minus 3 over 2b plus a half a. Collect like terms, so equals half a minus a half b. So this is n to m. Then we've got to work out n to c. So n to c is, I'm going to take this route here, n to a plus a to c. N to a is minus 2b, and a to c is plus 2a. Now if you compare these, if I rewrite this one to a minus 2b, you can see that this is 4 times that, and so therefore you've proved it's a straight line. One other type which is similar is they will ask you to prove that something is parallel. Same thing. If you've got a line vector there and then you've got a vector over here, as long as this is a multiple of this, you've proved it's parallel. It's going to be in the same orientation. So R to S parallel to O to Q. So we first thing the question will work out is what is O to S. So with this one, this is midpoint again. So O to S is, we have to work out, we can work out P to Q. So we're going to work out O to P plus P to S. Now O to P is P. P to S is half P to Q, which equals P plus a half. Now P to Q is minus P plus Q. So that equals P minus a half P plus a half q. So in total that will equal a half q plus a half p. So now we go to this bit. So we've got r to s. R to s will be this, r to p, plus p to s. Now r to p is a half p, and p to s will be what we worked out here. So minus a half p plus a half q. So r to s is just a half q. Then we've got O to q. Now O to q is already q. So we can then see, times that by 2, and that will give us a multiple, and so therefore it's proved parallel.